Welcome to another GCBASIC demonstration. This one a bit more complex, but it's still for the AVR DX. It's part of the implementation. And they're pulling together the interrupts that we demonstrated in previous videos with the ADC operations, which happened to be in the last video. So what we're going to do is use the interrupt to read an ADC. What have I got? I've got an AVR DX board. See now 4809 could be done. It should be, you can use this with any of this range. So I went into this before, but we're going to read a analog to digital conversion using, it's called the ADC, and we're going to run that conversion and put the results on a serial terminal. But this time it's going to be driven by an interrupt. I am using this board. I showed you this last time. I'm using one of the green ports. And that green port that I happen to be using is AN1, which is attached to PD0. And I explained in the previous video that the configuration of that port is fully automatic, determined on the name AIN1. If you've picked one of the others, it will configure it automatically. I've got a potentiometer hooked up. I will show you that first. Go out to desk cam. I have a potentiometer. If I rotate the potentiometer, I get different results. I've got 3 volts from the board onto one side of the brush. The ground is on the other side of the brush, and I'm reading the middle brush, the middle into my ADC port. And as you can see, there's an LED flashing every half a second. Yeah, it's just flashing every half a second. That is not coming, that is just something that's happening in the background whilst the ADC reads are going on, just to prove that things are happening. But we'll look at the code. Back to my program, and this is what I've got connected to AIN1, a 3 volt supply on the high side, ground on the low side with a potentiometer. Mine happens to be 10K. Very simple. You can put a capacitor on. Also, please do your own research on that. So what I'm going to do, I'm going to initialize everything, set up the timer, set up the interrupt, and I'm going to flash the LED forever. And you're seeing that already. And it's just going to loop back forever and do that forever. It's going to keep flashing that LED. However, every time there's an interrupt, it'll read the ADC and it will show the results on a serial terminal. Oh, that sounds ominous. Let's have a look at that. And if I go into what I nicknamed Zen mode, you can see it on the screen. Every second, and you might not, it's every second? Yeah. It's a clock running like 16, 17, 54, 55, 56, 57, something every second is chirping away and saying, read the ADC. So I can rotate this to 0, and every second it will take a new sample full on. And you can see it's every second. It's not instantaneous. It could be the shortest period that you want, but this is just a demonstrator. So let's go back to mine. So let's have a look at what we're going to do. Look at the sample code, look at the results, and then I'll change that program to show what I call an interrupt flag method, and it's the preferred method I use. Let's look at some code. I'm going to go into Zen mode, and so on there we can now see the whole program alongside the camera. That works well. So let's look at the whole program. Well, I know that we're going to be using a 4809, so I have to specify that at the top, and I have to set up my USART. And I'm using USART 3, so I specify a couple of constants, 3 constants, to specify the baud rate, and that I want to send all the data out, and I don't want any delays, okay? Just get it out there. The next section, I'm going to put a string on the screen, which is here. It prints a screen, a serial string straight to the terminal. And we can see that. And I'll put a delay in there because I learned at the last, wait 4 seconds, at least you can see it, okay? And then I initialize the timer. And this is how we initialize the timer. It is essentially init timer 0. We're using timer 0, using the internal oscillator, and I'm going to be using a scaler of 1024. I set the timer 0 to a value, and that value equates to 1 second, and there's many calculators out there that will give you that value. I'll start the timer, and now the timer is running. So how do I set up the interrupt? Well, basically every time this timer 0 overflows or becomes 0, it will call this thing called ISR. What's in ISR is a little subroutine that says print out the ADC value. And that's what we're seeing. So that is running every second. But what's running in the interim period is this little loop up here, and this is permanently running, which says basically pulse out on port F5. That's where the LED is. 25 milliseconds. I could change that to 50 milliseconds. And I want it just to look nice every half a second. I can then press function key F5 on my keyboard, and it will then program it. You'll see the LED change because it will. There we go. We can see it. Pulse. There we go. It's happy. It's settled down. I'll close that dialog. And if we now look at the terminal, and if I just do it a bit quicker, we can see the whole event. Program that. We'll see that it will put out my string, ADC read, with interrupt every 1 second hidden behind the camera. At first read is always 0. And now we're back into our program. And we can change that to be an 8-bit read or a 10-bit read. But that's how it's working. The loop is continually flashing the LED, and then every 1 second, the timer is getting called and is doing its interrupt. All the flags, etc., are all being set up automatically within GCBASIC to make it easy. But they are there. You can look at the assembler, and you'll see that the registers required to set up the timer have been set up, that the global interrupt flags have been set up, the timers have flags or interrupt flags are cleared, but that is something that is documented, and all we've done is just captured that knowledge inside the back-end program, and that happens automatically. So let's just change the program now. We can change it dramatically. I'm going to show you a flag method. And what I tend to do is run my main loop, look for them, have many different events in my ISR, and when my ISR happens, I just set a flag. So I'm going to take that out and put it inside my main loop, and then I'm going to say if ISR flag is true, because I'm going to make a equals true, then print out value, and then I'm just going to set that to false. And I'll explain, this is my logic that goes, essentially, I'm going to set this ISR flag to true inside of my ISR. So the only time it will be true is when the ISR is true. And if you want to know how to declare a variable, I dimension ISR as a bit. It's either set to 1 or 0, and that equates to true or false. So if I now program that, we get a very similar program. It won't look a lot different in, oh, what did I do wrong in here? Oh, typo down here, look. It told me where the loop error was, so I could just correct the end if there. And now it's going to flash just the same as it was before. There we go. It's flashing as it was before. And in the terminal, we've still got the 1 second. But what is different about the two approaches is that the ISR itself is faster. It gets in and out of the ISR very quickly. It doesn't have to do all the reading of the ADC and all the printing on the screen and all the serial operations. It sets 1 bit and exits. So we could have a look at that inside of the assembler, which would be quite useful. To look at the assembler, I want to search for this subroutine called ISR, and to open up the assembler, press Shift F7 or take the option from the F4 menu. If I do a search in here for ISR, that's not the subroutine, and here is the whole of the ISR. It says ISR flag equals true, and it sets me up a bit variable. There we go. It says this is essentially set up the bit variable to true, which is, and this system variable has been created automatically, and it's bit 0 in there, and it set it to 1. And that is all that happens. Now, how's that all called? We can have a look in here. Lots of stuff. This is the interrupt vectors, and it says here something set up this jump here for this timer. That's the timer interrupt. I can search for that, and it says in here, save the system context, call the ISR, which we know is very rapid. It clears the interrupt flag for you automatically and then restores the context. Now that context can change. Why does it change? It changes as the program grows. So if it knows it needs to save a variable, it will save a variable for you. And we can do a search for this, what context is being saved. For this particular one, it says here, whenever an interrupt happens, take a copy of this particular byte variable because it will get overwritten. It could get overwritten inside of the ISR. Fully automatic, very simple. So there we go. That's the way you can set up a really simple ISR flag. I'm going to revert this program because it's a demonstration program. I think I'll leave that in there because I did like that. There we go. Function key F5 to reprogram it. Job done. So we set up read ADC. What have I done wrong? Oh, missed off the units. Typical of me. I'm going to go back to my PowerPoint once that flashes. Great. And now we can see it putting out the values back on the serial terminal as it did before, every 1 second. Great. I wanted to show you interrupt-driven ADC operations. They're very simple. Enjoy.